Good evening, all. Welcome to today's live discussion session for the NPTEL course Soil Mechanics Geotechnical Engineering I. I'm Reshma R, Research Scholar from the Civil Engineering Department, IIT Madras. I shall share my screen now. Hope it is visible for you.
Yes, madam.
Okay, so we'll begin today's session. So, here is the first question for today's session. If the available shearing resistance and the mobilized shearing resistance of any slope section are denoted by tau F and tau respectively, the factor of safety of the slope is. So, the available shearing resistance is denoted by the letter tau F and mobilized shearing resistance by tau. Then, how do we represent factor of safety? You can type in the answers in the chat box. So, which is the correct option? Option A, tau F by tau. Option B, tau by tau F. Option C, 2 tau F by tau. And option D, square root of tau F by tau. So, which is the correct expression for factor of safety of the slope given the available shearing resistance and mobilized shearing resistance of the slope? Which one is the correct option?
Option A, madam.
Any other answers? You can type in the answers in the chat box also. Okay, let's see which is the correct option. Correct option is answer A. And the correct answer is option A. So, factor of safety of a slope against sliding is given by uh, it depends upon the type of soil as well as the condition of soil. So, first for the cohesionless soil, it is given by the general equation itself, that is shearing resistance by mobilized shearing resistance, which is equal to tau F by tau or tan phi by tan beta, where phi is the angle of internal friction and beta is the angle made by the slope with the horizontal. That is the magnitude of the slope. So, for a cohesionless soil, factor of safety is given by tau F by tau or tan phi by tan beta. For a submerged slope, that is the case where the groundwater table is above the considered surface. So, for a submerged slope, the factor of safety equation becomes gamma submerged tan phi by gamma saturated tan beta. Gamma submerged is obtained by deducting gamma W from gamma sat or saturated unit weight. That is, submerged unit weight gamma sub is equal to gamma sat minus gamma W. So this is the equation for a submerged slope. Now, for a cohesive soil, the the numerator becomes C plus sigma tan phi. While considering the shearing resistance, the equation becomes C plus sigma tan phi, as we have learned in the previous classes. The resistance becomes C plus sigma tan phi. So, moving on to the next question. A slope of infinite extent is made up of dense sand layer. Slope is inclined to the horizontal axis at an angle of 25 degrees. Determine the factor of safety of the slope against shear failure if the angle of internal friction of the soil is 35 degrees. So, we are given that the slope is of infinite extent. It is sandy soil, so that is cohesionless soil. The inclination of the slope to the horizontal axis is given as 25 degrees, and the internal friction, angle of internal friction, is given as 35 degrees. We are asked to determine the factor of safety of the slope against shear failure. Option A 1.01, option B 1.05, option C 1.50, option D 1.30. Which is the correct option? We are given the inclination with the horizontal and the angle of internal friction. Okay, I have got one answer in the chat box. Any other
Option
answers?
C, madam.
Yes, on answer in the chat box also option C. So let's see which is the correct option. Yes, correct option is option C. So we are given the inclination of slope with horizontal axis beta is equal to 25 degrees. Angle of internal friction of the soil phi is equal to 35 degrees. So from the previous question, we know that factor of safety of the slope against shear failure can be represented by tan phi by tan beta. Substituting the values of phi and beta as 35 and 25 respectively, we have factor of safety of the given slope against shear failure is equal to 1.5, that is option C. All right, so moving on to the third question. A granular soil possesses saturated unit weight of 20 kilonewton per meter cube. Its effective angle of internal friction is 30 degree. A slope is to be made of this material. If the factor of safety is to be 1.25 and unit weight of water is 9.81 kilonewton per meter cube, the safe angle of the slope is given. Seepage occurs at and parallel to the surface of the slope. So here we are given a granular soil sample with saturated unit weight of 20 kilonewton per meter cube and angle of internal friction 30 degree. To make a slope with a factor of safety 1.25, what should be the safe angle of the slope is the question. We are asked to determine the angle made by the slope with the horizontal if the required factor of safety is 1.25. We are given the saturated unit weight of the soil sample, effective angle of internal friction, as well as the required factor of safety. Option A 10.12 degrees, option B 15.1 degree, option C 22.12 degrees, option D 13.24 degrees. Which is the correct option?
Option D, madam.
Okay. Yes, I have another answer in the chat box also as option D. So let's see which is the correct option. Yes, correct answer is option B. So here we are given saturated unit weight of the of the soil sample as gamma saturated 20 kilonewton per meter cube. Effective angle of internal friction phi as 30 degrees. Factor of safety as 1.25. Unit weight of water gamma W is 9.81 kilonewton per meter cube. So, as we saw in the first question, factor of safety of the slope against shear failure for a submerged slope is given by gamma sub into tan phi by gamma sat tan beta. This value is given as 1.25. That is, our required factor of safety is 1.25. We are given all the other values except beta. So, beta we are asked to find out, that is a safe slope that is required to obtain a factor of safety of 1.25. So, We know that gamma submerged is equal to gamma saturated minus gamma W. So gamma saturated is given in the question. Substituting, we have 20 minus 9.81 tan 30 by 20 tan beta is equal to 1.25, or tan beta is equal to 0.2353. So taking the inverse, we have beta is equal to 13.24 degrees. That is option D. Hope that is clear. So moving on to the fourth question. For the trial slip circle shown in the figure with W is equal to 380 kilonewton, unit weight of soil gamma is equal to 18 kilonewton per meter cube, angle of internal friction phi is equal to 0 degrees, and cohesion C is equal to 28 kilonewton per meter square. The value of restoring moment in kilonewton per meter for the slope shown in the figure is. So, we are given a trial slip circle as shown in the figure, where W, the weight is given by total weight of the soil wedge. W is given as 380 kilonewton. Unit weight of the soil sample is given as 18 kilonewton per meter cube, and cohesion is given as 28. So the soil is cohesive soil. All the previous questions were dealing with cohesion less soil. This one is cohesive soil. We are asked to determine the value of restoring moment for the slope. So option A 2245.16, option B 3346.56, option C 4643.03, option D 1373.17. So the total height is given in the figure as 8 meter, and all the other values are provided in the figure itself. Like the distance from the like the angle with the horizontal, the total height, everything is provided in the figure. So what is the value of the restoring moment?
Option B, madam.
Okay, so yes, in the chat box also I have one answer, option B. So we'll see what is the correct answer. Yes, correct
Madam,
answer. Yes.
in the question, moment units are wrong, madam. Please correct it.
Oh, sorry. Okay, it is kilonewton meter. Sorry. Yeah.
It's okay, madam.
One second. Let me correct that. Thank you for
Yes, madam. Thank you.
telling. Okay. So, okay. So we'll see the correct answer is option B. And here we are given the weight of the soil wedge. W is equal to 380 kilonewton. Unit weight of soil gamma is equal to 18 kilonewton per meter cube. Angle of internal friction phi is equal to 0 degrees, and cohesion C is equal to 28 kilonewton per meter square. So, this is the figure given in the question. So, restoring moment equation is given as mr. Restoring moment mr is equal to c r square theta. So, C is the cohesion, which is given as 28 kilonewton per meter square. Now, R is the radius, that is given as 8 meter in the figure. Then theta, it is given in the figure as 107 degrees. So when theta is used outside any trigonometric function, for example, when it is not within sine, cos, tan, sine inverse, cosec, or something like that, we have to substitute theta always in radians. When we are putting inside sine, cos, or any other trigonometric function, we can put as such in degrees. But whenever it stands alone, independent, we have to substitute theta in radians. So converting theta in degrees to radians, we have to multiply that value with pi by 180. So That's why we have a pi by 180 term in the equation. So the storing moment, after substituting all the values, we have it as 3346.56 kilonewton meter. So that is the restoring moment in this case. Okay. So moving on to the next question. So for the trial slip circle, as we saw in the earlier question, with the same parameters, here we are asked to find out the value of sliding moment. Once again. Okay, we are asked to find out the value of sliding moment. So here also the weight of the soil wedge is 380 kilonewton. Unit weight of soil sample is 18 kilonewton per meter cube. Phi is 0 degrees and cohesion C is given as 28 kilonewton per meter square. Earlier in the previous question, we were asked to determine the restoring moment. Here we are asked to determine the sliding moment. So option A 1900, option B 1700, option C 1100 and option D 2100. Which is the value of sliding moment in this case?
Option A, madam.
Okay. Okay, in the chat box also, one answer is option A. So we'll see which is the correct option. Yes, correct option is option A. So here we are given the weight of the soil wedge as 380 kilonewtons, unit weight of the soil sample as 18 kilonewton per meter cube, angle of internal friction as 0 degrees, and cohesion as 28 kilonewton per meter square. The slope case is the similar one as that in the previous question. Earlier we solved for restoring moment. Here we are solving for sliding moment. So sliding moment ms is given by w into d. That is the soil wedge. The weight of the soil wedge causes the sliding action. So it will be the weight into lever arm. That is here it is d. And so substituting the values we have, weight w is given by 380 and d is 5 meter from that point as shown in the figure. So we get sliding moment is equal to 1900 kilonewton meter. That is option A. All right. So moving on to the next question. Again, for the same trial slip circle with weight of soil wedge 380 kilonewton, unit weight of soil 18 kilonewton per meter cube, phi 0 degrees and cohesion 28 kilonewton per meter square, we are asked to determine factor of safety against sliding failure of the slope section in the figure. So already we have determined restoring moment and the sliding moment. Both cause and reaction we have already determined. Here we are asked to determine the factor of safety against sliding failure. Option A 1.14, option B 1.76, option C 1.83 and option D 1.25. Which is the correct option?
Option B, madam.
Okay. Yes, the same is there in the chat box also. So, yes, correct answer is option B. So, we are given the weight of the soil wedge as 380 kilonewton, unit weight of soil as 18 kilonewton per meter cube, angle of internal friction phi as 0 degrees, and cohesion C as 28 kilonewton per meter square. So, this was the soil slope that we were given. So when we have to determine the factor of safety against sliding, we need to determine both the restoring moment and the sliding moment. So first, considering the restoring moment, mr is equal to c r square theta, as we saw in the previous question. So in this question, C is equal to 28, R is equal to 8, and theta is equal to 107 degrees. So we got the restoring moment as 3346.56 kilonewton meter. Always remember, whenever we are using theta independently, it should be substituted in radians. For converting theta in degrees to theta in radian, multiply it with pi by 180. Okay. So next thing we have to determine is the sliding moment, which is given by weight of the soil wedge into the distance. So that perpendicular distance. So that is 5 here, 5 meters here, and the weight is 380. So we got the sliding moment value as 1900 kilonewton meter. Till this we had calculated in the previous problems. So in this question, we were asked to determine the factor of safety against sliding, which is given by restoring moment by sliding moment, which is equal to 3346.56 divided by 1900, which is equal to 1.76. So factor of safety, another equation is restoring moment by sliding moment. Okay, so let's move on to the next question. If an infinite slope of clay at a depth of 8 meter has mobilized cohesion of 38 kilonewton per meter square and unit weight gamma 18 kilonewton per meter cube, the stability number is. So we are given that the slope is of infinite extent and the soil's material is clay, that is cohesive in nature. It is found at a depth of 8 meter, and the mobilized cohesion, the magnitude of mobilized cohesion is 38, and the unit weight is 18 kilonewton per meter cube. We are asked to determine the stability number. Option A, 0.15, option B, zero point 0.1, option C, 0.26, option D, 0.38. We are given the mobilized cohesion, unit weight, and the depth at which this soil clay layer, clay slope exists. So which is the correct option? What is the stability number in this case?
Option C, madam.
Okay, let's see. So yes, correct answer is option C. So we are given the depth at which infinite slope of clay exists is 8 meter. Mobilized cohesion is 38 kilonewton per meter square and unit weight is 18 kilonewton per meter cube. So stability number Sn is equal to Cm by gamma h. Stability number Sn is given by Cm by gamma h. All the values are given. So simply substituting, we have stability number is equal to 38 by 18 into 8, which gives a value 0.264. Hope it's clear till now. Moving on to the next question. A slope of one vertical is to two horizontal is to be made in a silty clay having an angle of internal friction of 5 degrees and a cohesion of 25 kilonewton per meter square. The unit weight of soil is 18.5 kilonewton per meter cube and depth of cut is 8 meter. The value of net normal and tangential force is 2554 kilonewton and 811 kilonewton respectively. Angle between starting point, origin and exit point of the assumed slip surface is 115 degrees. Lever arm distance between origin and exit point of the slip surface is provided as 15.8 degrees. Sorry, 15.8 meter. Lever arm distance is 15.8 meter. So instead of giving a figure as in the previous question, here we have a descriptive question. That is the only difference. We are asked to determine the factor of safety of the slope by Swedish circle method. So here the required slope is 1 vertical is to 2 horizontal. The material is silty clay with an internal friction value of 5 degree, and the cohesion C is 25 kilonewton per meter square. The unit weight of soil is 18.5 kilonewton per meter cube, and depth of the cut, that is 8 meter. Here the net normal force is 2554 kilonewton and net tangential force is 811 kilonewton. Lever arm distance is 15.8 meters and angle is 115 degrees. But here we are asked to use the equation by Swedish circle method. Option A 1.25, option B 1.65, option C 1.15, option D 0.95. Which is the correct option? Which is the correct value of factor of safety using Swedish circle method?
Option A, I hope.
Okay, yeah, as I have answered in the chat box also. Yes, option A is there in the chat box also. So let's see which is the correct option. Yes, correct option is option A. So here we are given that the slope, the required slope is 1 vertical is to 2 horizontal. Angle of internal friction phi is equal to 5 degrees. Cohesion C is equal to 25 kilonewton per meter square. Unit weight of soil gamma is equal to 18.5 kilonewton per meter cube. Depth of cut is given as 8 meter. Net normal force is equal to 2554 kilonewton and net tangential force is 811 kilonewton. Also, the angle between starting point, origin, and exit point of the assumed slip surface, that is theta, is given as 115 degrees. Lever arm distance between the origin and exit point of the slip surface, that is capital R, is equal to 15.8 meters. So, according to Swedish circle method, factor of safety is given by CR theta plus sigma n tan phi divided by sigma t. So all the values are given here. We need to substitute. So here also we have to substitute theta in radians. So first converting that one given theta into radians, we have theta as 2.007 radians. Then substituting all the values, factor of safety we obtain as 1.25. So factor of safety obtained using Swedish circle method is 1.25, that is option A. So with this we have come to an end for today's live discussion session. If there are any doubts, please unmute yourself and please proceed. if you have any doubts regarding today's session.
Thank you, madam.
Yes, thank you. So, if you have any doubts,
Madam, in the last problem, madam,
yes, yes.
the last problem, the slope is given. That's what is the use of that slope, madam? Even 1:1 also same procedure, madam.
No,
One
sometimes in
vertical to
the,
two horizontal something is
yes,
there.
yes, sometimes in the problem they will be given so many what do you call parameters that are not actually required to calculate what is asked in the question. So it is our, what do you call, we have to judge which all factors we have to use, because if someone does not know the equation, they will be trying to put in all the values that is given in the question, right? So that's why they have given so many things in the question. So many unwanted information about the slope surface will be provided, or about any, if it is any question, any subject also, you should be careful that in the question there can be many things. But the procedure you need to adopt solve a problem should be, first see what is asked in the question, write down the equation whatever you know related to that particular question. That is, in this case, they have asked to determine the factor of safety of the slope by Swedish circle method. So once you see that, you should be able to understand that is the question part of the problem, and then recollect the equation related to that and note down that particular equation. Then you will get what all parameters you need to solve that problem, right? So then you can like pick up or pick out all the please mute yourself. Okay, thank you. So once you get the equation, you will get to know which all parameters you actually need to solve that problem, so that you can easily rule out all the other unwanted information in the question and proceed with solving.
Okay, that is extra additional information.
Yes, yes. Usually, in almost all the competitive exams, this will be there. Additional information they will always give. And the answers in the option will be such that somehow, if you what do you call, have a combination of these values, you will get one or the other answer in the option, definitely, even if you use the correct
Yes,
equation or the wrong ones. So that is why they are being given, to confuse the students. So you should be clear about the equation that is to be used.
madam.
Yes.
Okay, madam. Thank you.
Okay, thank
Madam,
you.
this is a doubt related to the examination.
Okay.
Earlier, earlier examination was computer based exam, madam. But
Okay.
I think this time they have made something like a paper pen. Is it correct, madam?
Actually, for some subjects it is, earlier also for some subjects it was paper pen, and some subjects it is computer based. So it will be given as a what do you call, information mail to you all. They will NPTEL team will mail you regarding which type of exam you will have to give for each subject.
It's
It
already given, madam. This time also computer based only, madam.
okay,
It's
okay.
already given.
Okay.
Computer based only. This time also computer based.
Okay, okay.
Okay, madam. Okay, madam.
Only certain subjects. I don't know exactly which all, but I have seen some subjects it will be paper pen, but most of them are computer based.
Yeah, yes, madam.
Yeah.
Fine, madam. Thank you,
Okay,
madam.
okay. Thank you, thank you.
Thank you, madam.
Okay. So, any other doubts? I'll stop sharing my screen. Mm, okay. So, any other doubts?
No, madam. Thank you very much for
Okay.
all presentations, madam. Nice presentations.
Thank
Thank you,
you.
madam.
Thank you. So one presentation actually was left out, like uh, I think it's the sixth one, that I will record separately and I will upload in the YouTube, and I'll share the link also in the Excel sheet. That class was actually cancelled because of some unavoidable situations. So I'll upload that class also in the YouTube, and I'll share the link.
Yes, madam. We'll go through, madam. Definitely.
Okay.
Thank you, madam.
Okay. Thank you. Thank you all.